Uh, Good morning, students. Welcome to our third laboratory experiment. And the name of our laboratory for today is three-phase power measurement. So kindly download the lab manual number 3 from the BB Learn on your blackboard. Download it and open it. Okay. Once you open, the title of your lab today is three-phase power measurement. Okay. So what equipments you need? What equipments is required, or are required in this laboratory. So first, you need a power supply. Of course, you will use the variable three-phase power supply. Next, you need an AC voltmeter, all right, and the range from 0 to 500. Okay. And you need also an AC ammeter, the range from 0 to 0.25 ampere. Okay? Alright? And then, of course, you'll be needing a three-phase wattmeter. This wattmeter will be used to measure the power input and the power output. Okay? And lastly, you'll be also needing a resistive load. Okay? So this resistive load, we will use the 1200 ohms. Got it? Okay, so those are the equipments needed on this experiment. Okay, students, let us start to connect the experiment number 3. Okay, so first of all, you need to have you need to use the variable three-phase power. Okay, so this variable three-phase power, all right, the 4, 5, 6, and N will be connected directly to the three-phase wattmeter. All right, three-phase wattmeter with the sequence code, or with the code 844128. All right, so 4, connect number 4 to the number 1 of the three-phase wattmeter. Alright? And 5 also will be connected to number 2 of the three-phase wattmeter. And 6 will be connected also to number 3 of the three-phase wattmeter. Alright? Okay. The next one is that you need to connect the voltmeter, the AC voltmeter. So out of 3, just select 1. Okay, as per indicated in the circuit, from your manual. All right. So connect. Okay, connect 4. Okay, the COM of the voltmeter, and 5 of the power supply. Okay, connect to the 500. So we will use the 500 range of this voltmeter. All right. Now, as you can see, we need an AC ammeter, right? An AC ammeter coming from the number 4. Okay, coming from number 4 of the power supply. Okay, connect to the ammeter before connecting it to number 1 of the three-phase wattmeter. So what you will do, remove the 1, okay, remove this one, okay, coming from wattmeter, the wire coming from number 1 of the wattmeter, remove it and connect it to to the AC ammeter, right, the plus minus. Okay, once you connect that, get another wire, connect this 0.25, okay, 0.25 range from the AC ammeter that you have connected, connect it back to number 1 of the three-phase wattmeter. Alright, got it? Okay, so now you can see that the AC ammeter is connected in series from number 4 of the power supply, number 4, going to number 1 of the three-phase wattmeter. Okay, as indicated in the as indicated in the circuit. Alright? Once you finish that one, so we will connect now the load, the resistive load. Okay, so how to connect the resistive load? So what you have to do is that from 4, 5, 6 of the 3-phase wattmeter, okay, connect the number 4 to a resistive load. Let's say I'm going to connect it here. Alright, the first resistive load, the number 4, the number 5, connect it to the second resistive load. Alright, and the number 6 of the 3-phase wattmeter, connect it to the last resistive load. Okay, got it? And once you're done, the other points of the resistive load, you connect it all together, no? To make it common, as per our circuit diagram from your manual. Okay, like that, no? Connect it together. Alright. Okay. Alright. So there you have it. This is the complete full set of connection, no? Of your what you call this? Laboratory number 3, no? The 3-phase power measurement. Now, since you common these 3, you can connect this one to neutral, no? You can connect it to neutral. Okay? Because why? Because you are connected in star connection, no? In common. Okay? So meaning you can connect it into neutral. So let's connect it to the neutral, no? To make it more safer. Okay? Here, neutral. Alright. So there you have it. This is the complete set connection now of your laboratory number 3. Okay? 3-phase power measurement. So what's the next step you need to do? What's the next step? So you need to do, go to your lab manual. No, go to your lab manual. And then, no, I have my lab manual here, no, at my side. So read the step number 2. Step number 2 said, set the resistor of each section to 1200. Okay, so let's set 1200 switch on, 1200 switch on, 1200 switch on. Okay, and then turn on the power supply, and adjust the line voltage to 415 volts AC as indicated by the voltmeter, no? As indicated from here. Okay, so you need to adjust this, no? You need to adjust this now until it will reach, no, the reading from this voltmeter, 415 volts. Got it? Okay, let's switch on. Okay, but before that, no, before you switch on, make sure you connect also the power, no, of the 3-phase wattmeter. So you will be needing this, no? So connect this one here, okay, to the center of the wattmeter, 3-phase wattmeter, and connect this one here, no, to the 24 volts DC power supply of our power supply. All right. So let us switch on. Now, why connect this? Why? Because this will not work unless we will input a power to it. Okay? So the input power should be 24 volts DC. Okay? All right. So let's switch on. Okay? And switch on also this. All right? So look at this, no? So we are starting from 0. Okay, the voltmeter voltage is 0, and let's increase it into 415 volts. Okay, so increase this. As you can see, no, the voltmeter is also increasing. So let's increase this until 415 volts. Okay, somewhere. Okay, I think the 415 volts is the maximum, no, of your knob, 100% of your knob. Okay, so as you can see, you have 415 volts here, and you have some reading here from the 3-phase wattmeter. All right. So once you got the measured value, write it down to your lab manual. Okay? So I'm gonna focus it, and you need to write it down to your lab manual. Alright, so this is the input voltage. Okay, that's the input voltage. And this is the power, no, measurement. Okay, right? And this is your current measurement. All right. Okay. So you have the readings and record it in your manual. All right. So return the voltage to 0. Okay. And turn off the power supply. All right. By the way, if you're asking which is P1, no? So this is your P1, no? Because in your manual it says I1, P1, and P2. Okay? I1 is this. Okay? The current. The P1 is this. Okay? This is your P1, and this is your P2. Got it? Okay. So let us go to the next procedure. So now, from the results that you have taken, no? From the measurements that you have taken from our experiment, okay? Calculate the three-phase, no, the apparent power, no, the power, the active power, the power factor, okay? And you need to answer if is the power factor close to the unity, and if it is close to the unity, click yes, and you explain why it is close to the unity. All right. All right. So now the next experiment, or the next step, is to replace the resistance module with capacitance module. So set the reactance to each sections to 1,200. Okay? So what we need to do? Alright, so I switch it off. Switch it off. Okay? So look for the resistance, no? The resistance module, or I mean, look for the capacitance module. Okay? So where's the capacitance module? This one, no? This is the capacitance module. Okay? So what you need to do is that, no? These three, just put it in the capacitance load. Okay? So remove one, put it there, like that. This one also, put it there. This one also, put it there. Okay? And also the common, no? So remove this. Okay? Remove this, put it there. And this one, like that. Alright? So I just transferred the connection from resistive load to capacitive load. Okay? Alright? So this is step number 4. Okay? This is step number 4. In step number 4, just remove all the connection here and transfer it here in the capacitive load. Okay? And then set the capacitive load with the reactance of 1,200. So 1,200, 1,200, 1,200. Okay? And then repeat the procedure of step number 2. Alright? So once you set it up, then switch it on, the power. Switch on the power also here. And then increase the voltage until you get 415. Okay? So increase. Okay? Increase. Check the current. Okay? Check the current. Make sure the current is not, it's not exceeding to the required rated current. Okay? So 415. Okay. All right. So this is the last, the maximum, the 100%. So basically, the reading here should be 415. All right. Once you're done, then get the voltage, get the current, get the measurement of P1, and get measurement of P2. Okay. All right. So let's get it. All right, so this is the voltage, okay, and this is the current, okay, and this is the, okay, sorry, it's, there's a lot of wires like that. So this is the P1 and P2. Look at that, no? The P2 is going to the other side, okay? So meaning the reading of P2 is negative, okay? So what you need to do, switch this, no? Switch this, switch here, down, no? Here. Okay, put it down in negative. All right? So now, when you put it in negative, the P1 is positive, no? Around positive 1, 2, 3, 4, 40, no? That is 40 watts. And the P2, no? This one, no? The P2 is negative 40. Okay? Got it? Why negative? Because we put the switch here negative. So this is negative 40. Okay? So it's negative 40. Okay? Again, P1 is positive 40. Why? Because that is positive reading. And the other one, the P2, is negative. Negative 40. Okay? Why? Because we switch here negative. If we put it back to positive, it will go to the other side, no? See? See that one? It went to the other side, no? No? See that? It went on the other side. If you switch it to positive. However, if you put it in negative, it will go to the positive. Alright? But the reading, when you write it down, it should be negative 40. Okay? In P2. Alright? Alright. Okay. Okay. So that is the second, no? And put it back to 0 again, the knob, and switch off the power. And what you need to do next is to calculate the apparent power, the active power, the power factor, okay? And that's it, okay? So we'll do two circuits only today, okay? We will not do the inductive load, okay? Basically, all right? Because we have some restrictions also, no limitations in our laboratory, all right? Thank you and good luck to your experiment.